In this initial video, I'll be outlining some basic coding concepts to help get you started with the idea of scripting. Then we'll look at creating a simple program and cover some basic terminology such as working with variables, operators, conditions, loops, etc., how to use functions and extending that into classes and objects, and then finally how to test and publish your first projects in ActionScript. So let's get started. Okay, let's start by discussing some coding concepts, and the reason I'm doing this is because I want to show you that you shouldn't feel overwhelmed by the idea of coding. If you've never done it before, it's actually just a fairly simple thought process behind the idea of scripting something out, and I want to show you how you can apply it to an everyday concept. So let's begin by looking at the basics. Whenever you're coding something, essentially, if you need to build something, you need to script it out, you need to break that task down into smaller steps. You shouldn't start with something really overwhelming and expect to be able to just type it out and complete it in one foul swoop. So for example, if you were told to produce a video game, a programmer doesn't just sit down and code that from start to finish, hit execute and boom, it's done. They build it in stages. Next thing you have to understand about coding is that it's about asking questions as you go. Programs rarely run from start to finish in just one go. What they typically do is they look at data, evaluate it, ask questions, etc., and then act on those decisions. So that's just it. You're making a series of decisions as you go through your program. So let's put this into the everyday life terms. You can do this with anything you like. It's something I like to do residentially. Let's start with something as simple as making a sandwich. You have to ask yourself, if I were doing this and pretend it's not as easy as it really is, what are the steps that are needed to make my sandwich? You got to choose the right ingredients. What do I want in my sandwich? What's it made of? You got to then go ahead and build the sandwich, create it, and then finally you get to eat it. So initially, you've got to start by thinking about ingredients. You choose your bread, but it's not simple as that. You've got to ask yourself another question: how many pieces do I need? How many rounds am I making? And you act on those questions, on the answers to those questions. So I'm going to start, I need 2 pieces of bread, 2 slices. Typically then you would apply butter to your bread. So then you're executing a command based on a previous decision. If I had just 1 piece of bread, I'd butter 1. I've selected 2, so I'm going to go ahead and butter 2. The result, I've got 2 pieces of buttered bread. The next thing you're going to say is, well, I need some cheese. And you could break this down into a series of questions, and you can repeat this step according to whoever's running the program, or whoever's making the sandwich in this case. So you apply a slice of cheese and you ask a question: is that enough? Is 1 slice enough? Well, no. I like lots of cheese on my sandwich, so I've got to go back and apply another slice. And I can ask another question: is that enough? Yes, in this case that's enough cheese. So I'm asking questions and I'm making decisions based on the answers to those questions. Do I want to add any other ingredients? You could perform the same questions for ham. What kind of ham? How many slices? How thick do you slice the ham? Do you want to add in any kind of mayonnaise, etc., etc.? So we're building this up in a series of steps, and the result is the completed sandwich. Now this might seem like a really kind of bizarre analogy, but it's the same practice when you're programming. You've just got to get into the habit of taking a complex task and breaking it down into a series of simple steps, and then essentially after that anything's possible. Okay, so enough with the analogies, let's actually get into some action scripting. So when you open up Flash for the first time, I'm sure you're familiar with this, and when you want to go ahead and create a new Flash document, what you would typically have been told is, well, create a new ActionScript 3 document. But if you haven't done any action scripting in the past, you might not necessarily understand why you're creating an ActionScript 3 document. Essentially, everything that's done in the background of Flash is is executing some kind of action script. And you may not know this, you may not realize this, but if you've done something as simple as a motion tween and you've set a path for it, you're actually executing a series of commands that say frame by frame move the object along that path. If you've added a button, you're saying when the user clicks on this button, execute this frame or go to this scene, etc. So in the background of all your Flash programs is this language known as ActionScript. ActionScript 3 is essentially just the current iteration, the newest version of ActionScript. The older version, ActionScript 2, has been put on here for compatibility. There is a difference between the two. There's no reason to go backward really, so everything we do in these videos will be using ActionScript 3. So let's go ahead and start a new document. Okay, so let's take a look at my timeline along the bottom. Now, typically when you're using Flash, you might start by, creating some objects and moving them around and adding some tweens and doing all that good stuff. The truth is, you can do that all within ActionScript alone. It's often easier to code repetitive things like creating 1,000 boxes, 10,000 boxes using code, and the code just goes ahead and executes and creates each one of those 10,000 boxes. If it's something more complex like a character design, then you might go ahead and use Flash's design tools to design your character, and you might combine that with ActionScript to define where the character moves, or if the user clicks on this box, the character moves here, if he clicks on this box, the character moves here, etc. So the simplest way to start adding ActionScript to your Flash files is to use the timeline. Now, you can essentially add ActionScript anywhere there is a keyframe on your timeline. So when you first start Flash, there's always an empty keyframe at frame 1, layer 1. So let's select that, right click, and we're going to select Actions from that menu. This will bring up the Actions palette, and this allows us to type in some ActionScript. And the way this works might look a bit confusing at first, but it's actually quite simple. What it's saying is, within your current document, you currently have layer 1 selected, and within layer 1 you currently have frame 1 selected. Now, let's go ahead and let's add a simple ActionScript command. So what I'll do is I'll use the trace command. I'm going to write this out, and whenever people do any kind of coding, any kind of scripting, the first thing they typically do is they write a hello world program, and this is just kind of a proof of concept. It's a test. In 3D you typically create a teapot, and in programming you write a program to write out hello world. So on frame 1, layer 1 of my document, I've added some ActionScript, and you can see on my first frame that a little A has appeared, which denotes that there is ActionScript contained within that keyframe. So what I can do now is I can actually go ahead and execute this to see if it works. Now, ActionScript actually executes when you run your Flash presentation. It executes the code according to the frame or the class or the object that's being called, etc. So in order to test this, I actually have to go ahead and build my Flash document. So I do this by going to Control, Test Movie, and we're going to test it in Flash Professional, and we just select Test. The shortcut to that is Control Enter, or if you're on a Mac, it's just Command Enter. So if I click Test, you can see it builds the Flash animation, and well, nothing's happened. Or hang on a sec, that's not right. Well, actually it is. The trace command works with the output window, and if you look down here in output, this is runtime output that gets spit out by your program. And as you can see, when I ran this animation, hello world, which I typed in up here, gets spit out in the output panel. Now, if I were to run this as a freestanding animation, I wouldn't be able to see this because the output panel is only available when you're testing a Flash animation. However, it's very useful for testing if code works, looking at what's in variables, etc. So with that idea, if I were to copy this piece of ActionScript that I had just typed in my actions frame, go back to my timeline, let's say add a new layer, layer 2. Layer 1, frame 1 has ActionScript in it. Well, let's select frame 1 in layer 2. Right click, actions. And let's go ahead and paste the same code in here. So what you'll see now is that there are different components or different chunks of ActionScript that I've now typed. You can see here scene 1, which is what I'm working on now, contains code on layer 1, frame 1, and layer 2, frame 1. So I can say I wanted to type something different here. Say if I wanted to say hello world again. What I can do is I can skip between these different chunks of ActionScript by using this little navigation here. So if I wanted to look at frame 1 on layer 1, I just select that and it has trace hello world, and that's located here. What I just pasted in and then adjusted was in layer 2, frame 1, here, which contains hello world again, and that's stored here. So in its most basic sense, you can store chunks of ActionScript on your timeline on different layers and at different keyframes. With that in mind then, let's try something. Let's delete layer 1 and let's adjust, well, let's delete the ActionScript that's currently there. You can see that's now another empty keyframe. Let's do something simple. Let's create a sphere. And let's modify, convert to symbol, and we'll call it ball. And let's create a motion tween. So fairly simple. And I want this ball to animate from there to there over 24 frames, or 1 second in this case. When it reaches the end of that transition, the end of that animation, I'd like it to execute some ActionScript. So what I'll do, to keep things separate, I like to keep my ActionScript in its own layer. So I'm going to create a new layer. I'll call it ActionScript. What I'll do is I'll create a blank keyframe on the final frame of this animation. I'll right click and select Actions, and then I'll type that same command that I had before, trace hello world. So what I'm expecting this to do is when I play my animation, it'll animate the ball and then it will spit out hello world into the output panel. So let's see if that works. I'll do Control Enter to test it. There you go. It's looping it again and again. You can see that when it gets to the end of the animation, it spits out hello world, and then it just repeats and keeps going. And as you can see by my scroll bar here, it's spitting out a new line every time it gets to that frame. That, in essence, is all there is to it, to adding ActionScript into your Flash animations. So let's look at a slightly more complex example, because if I were to, let's save this to my desktop. Bad practice, I know, but let's save this and let's call this hello world. I can see if I load up my desktop, I can see I've saved the Flash project here. When I build the Flash project, what it does is it creates that built file, or that Flash movie here, hello world.swift. If I were to run this in the freestanding Flash player, this is all I get. I don't get that output because that only exists in the testing environment within Flash itself, so my viewer wouldn't get that writing. So if I wanted to deliver that hello world message to my viewer, I have to do it in a different way. So I'll create a new ActionScript 3 document, and I think I'll clear this output because I don't really want that there now. So I'm just going to click on the drop down for the output window and select clear. That clears that out. I'll go back to my timeline and let's explore a different way of doing this. Instead of spitting that text to my output, what I'm going to do is at runtime, in other words when that animation or that Swift file is executed, I'm going to spit out text to a text field on my stage, and my stage is just my canvas here. So what I'll do is I'll select my first keyframe because I want this to execute straight away, actions, just like before. This time though, I'm going to do it slightly differently. What I'll do is create a series of commands and a variable, and this will create the text field, put text in it, and then display it on the stage. Now, this is kind of jumping in with both feet, but I'll explain this and break it down bit by bit through this video. So let's start. Let's create a variable, give it a name, and give it a type. Text field equals new text field. Okay, this is going to look a little Greek to begin with, but let me explain what's going on here. If I were to create text in Flash without using ActionScript directly, all I'd do is I'd select my text tool, I'd draw a text region, and then I'd type in some text. What I've actually done is created an object which is a text field, and then I filled in that object with some text. So I've applied some text to that object. All I'm doing now is applying the same principle but just typing it directly in code. So what I'm saying is I'm going to create a new location in memory which is a text field. Go ahead and build it. Then what I'm going to say is, alright, I need some text in my text field. I use the same text, hello world. So what I've done is I've built my text field, I've filled it with some text, and lastly I'm going to place my text field onto the stage. Now when I typed this, what you'll have noticed is that this popped up, import flash.text.text field. Now this is really useful, and it's also really important to know what this is. Whenever you're doing something in code, regardless of the language you're using, there's always a predefined set of functions or code which does something, a useful repetitive task. There's no point in reinventing the wheel every time you start a new program, a new script, or in this case a new action script. For example, to put it into an analogy of common world analogy, I don't need to know how to build a car in order to drive my car. I just accept that someone else who's smarter than me knows how to build a car, has built it well. All I need to do is know how to use that car and how to drive it. In this case, somebody else has already written the code that defines how to create a text field. I am accessing the instructions that have been written, or the library that's been written, and this is just a hierarchy of how to get to that library. It's located as part of Flash, it's part of the text library, and most specifically of all, it's the text field library. What I'm doing is I'm saying, build me a text field, an object of type text field. Go ahead and build it, and then just like I would say, I know how to drive my car, I'm going to say I know how to fill my text field with text. I fill it with text, and I apply it. I didn't need to know how to build a text field from scratch, how to define it, how to build it, how to invent it in ActionScript. That's been done for me. So I use that pre-existing code or set of instructions, and I just create it, put some text in, and apply it. So let's build this and see what it does. So Control Enter. Okay. This time, when my program runs, instead of spitting text out to the output field, what it does is it, in real time, creates the text field on the stage, fills it with text, and pops it onto the stage. Why is it in the top left-hand corner? Because I didn't tell it where to put it. So by default, it appears at 0, 0, which is the top left-hand corner. So this is X, this is Y. It might seem a bit reverse, but it starts in the top left-hand corner at 0, 0. Okay, so with a basic example out the way, let's actually step back a bit and let's talk about some programming concepts. The first thing I want to introduce you to are the idea of variables. Now, you've already heard me mention this, but what is a variable? Well, quite simply, it's a location in memory, or your random access memory, your RAM, where you store data while your script is running. So, say for example, you're doing a script which is a game, an action script which is a game that needs to keep a score. And the score needs to change, but you need some way of referencing what the score is and how to add 1 to the score. You need to store the score somewhere. So the score could be a variable in memory where I keep track of that while my program is running. Now, more specifically than this, you need to know that there are different types of variables for different types of data. For example, I need to use one type of variable to store a number and another type of variable to store a word or a letter, for example. So let's take a look at the different ones that we have then. To start with, we have what's known as an integer, and that's a location in memory where I can store a number, a whole number, and it can be positive or negative. So for example, 5 or -5. Then we have what's known as an unsigned integer, which is only positive numbers. There are no negatives. So I could store, for example, the number 5. Then when we're doing things like complex maths calculations, we can store what are known as floating point numbers. And that just means a number which has a decimal point and a fraction after that. So 5.34, a more specific number. Then we have a string, and a string is essentially just where you would store a word. So it's really a string of characters, so hello for example. And lastly is the Boolean, which is simply a value that can either be true or false. Has the player lost the game, true or false? Now another way of writing that is a 1 for true or a 0 for false. So you have to select the type of variable when you allocate memory to your Flash script. You have to select the type of variable that's appropriate to the type of data that you're storing. Back in Flash then, let's create a new ActionScript 3 document, and let's go back to our timeline, and I'm going to apply some ActionScript to show you how to format and test creating variables. So let's right click on frame 1, select actions, and we'll place some code at frame 1. So let's start by before we get into this, I'd like to quickly mention commenting. Comments are something that you're probably familiar with if you've done HTML or CSS. It's a means of reminding yourself why you typed some code or what that code does if it's a little complex. A comment is ignored when you run your Flash animation. It gets ignored. It's just there for the person writing the code, or if someone else wants to look at your script. To apply a comment, all we need to do is use 2 forward slashes like that, and what you'll notice is it turns green because Flash is actually color coding, so it's easier to read. So my first comment might be testing variables. I should have said grey, not green, sorry. So what I'm doing is I'm reminding myself what this code is doing. So maybe to begin with, I would like to create an integer, and if I remind myself, this stores a number, a whole number. I should put this in here, a whole number. The way I do this then is I use the keyword var, which stands for variable. Whenever something's protected and it's considered a keyword in ActionScript, it turns blue, which tells you that essentially that it's reserved for a specific purpose, in this case to create a variable. So I'm going to create my first variable, which is an integer, and remember this is a location in memory that gets assigned to my animation when I run my Flash program. So the first thing we need to do is assign a name. How do you refer to this location in memory? So what I'll do is I'll call it my integer, just like that. And I should be cautious to mention here that ActionScript is case sensitive. It's not as free, or some might say sloppy, as HTML, which allows you to type stuff in caps or in lowercase. What I've done here is I've used lowercase and then followed by a capital I for integer. Whenever I refer to this location in memory, I have to write it in exactly the same way. So when I've done that, I use a colon and I say this variable is of type int for integer, which means it can only store whole numbers, positive or negative. Whenever I type something in ActionScript, each time I've finished a line of code, I have to use a semicolon to say that's the last line of code. Now what's interesting to note here is that ActionScript is actually, or the editor here, is actually assigning numbers to my lines of code. This is very useful later on when we're looking to see if we've made any mistakes. It'll tell you which number or which line you should look at where there's a potential mistake. So I've created an integer. Well, what has that done to me so far? Well, nothing. If I control enter and run the program, absolutely nothing happens. And why should it? All I've done is reserved some space in memory to store a number. Well, let's actually store a number. So I'll add a comment, store value in my integer. And remember, I just made up that name, my integer. So let's do it like this. My integer, I'm going to use the equals command, and I'm going to give it a value of -10. Just like that. So when I run this program, control enter, nothing happens. But behind the scenes, I've allocated an area in memory for a type integer. In my program, it's being referred to as my integer, and it's also been assigned a value of -10. I just haven't done anything with it. So let's use that familiar trace command. I'll add a comment and I'll say output my integer to output panel. So remember, we use trace, and instead of typing in some text, what I can do is place directly in there my integer, end the line. So control enter. What happens when my program runs? If I look at my output down here, my integer gets created, it gets assigned a value of -10, and that trace command spits that value to the output field. So what we're doing is we're using a variable and we're assigning a value, and we're actually making use of that value. And this is a very simple proof of concept, but it works, and it's exactly what is needed to create a program that's useful, a program that will do something, that might request data from your users. You need to be able to store that data somewhere. So let's try a different kind of variable now. Let's create an unsigned integer, and I can do it all in one go in this first frame of my Flash animation. And what I'll do is I'll add another comment and I'll create an unsigned integer. There's very similar syntax to before. Variable, I'm creating a variable, then I give it a name. I'm going to call it my uint, which just stands for unsigned integer. I just made that up. You can put anything you want there. The type of variable that it is then is uint. Now, things you'll need to remember are the syntax, the way I'm writing this out, and the types of variables. And you can always refer to your book for clarification on this, but eventually you just get used to it, you remember it, and it becomes second nature. Now previously what I did was I created my variable, and then on another line I assigned it a value. It's useful to know you can do that all in one line just to save time. So I can do equals, and remember uints or unsigned integers can only contain positive numbers, so I'll give it a value of 7 and end the line. I've created a new variable, space in memory. It's called my uint, so I know how to refer to it, and I've assigned it a value of 7. That is stored in my RAM when this animation runs. And then what I'll do is I'll do exactly what I did before. Output, let's be consistent here, my uint to output panel. Same as before, trace, and this time I'm going to feed it my uint, being very careful to type it exactly as I wrote it initially. So let's test this, let's see what it does. Control Enter. You can see when my program runs now it spits out my integer and my unsigned integer, because when I execute my script here, what's happening is it's every time it's going from lines 1 all the way down to line 16, and it's executing them in this order. So we've created an integer and we've created an unsigned integer. Let's create a different sort here. Let's create floating point and output. You want to be efficient with your commenting. You want to give enough comments so it's clear, but you don't want to have, overload, so it's just there are more comments than there are actual lines of code. So let's combine these into one. So I'll create a variable. I'll call it my float, and the type is number with a capital M. I know I've got it right because it's gone blue. It's a reserved keyword. If I typed it wrong, say with a lowercase n, you can see that it's black, and that tells me I've made a mistake. I should expect that reserved keyword to go blue. So that's a floating point. I'll give it a value of 23.56. End the line with a semicolon. And then I'll execute my trace command. Trace my float. Let's test it. Yep, all three numbers are being spit out, so I know my code is working. So that's how I create a floating point variable. Moving on then, let's create a string. Seems my comments are getting more brief as I do this. String, variable, let's call it my text. You don't want to be creating spaces when you type these. You want to keep them all as one word. So what I do is I use what's known as the humpback naming convention, which is lowercase for the first word, and uppercase capital for the first or for the next word, and uppercase capital for the next, etc. It's easy to read. So then I'll use type string with a capital S. So be cautious here. Lowercase for integer, uint, uppercase for number, uppercase for string. So I'm creating an area in memory which specifically holds text. Let's give it some text. And notice the way I'm writing this out, the syntax I'm using. I feed that text into the string using these double quotes here. And I'm just going to feed the word hello into that area in memory. And we can test it by tracing my text. Test it. And it works. It spits out my text which contains hello. So remember, there's a difference between the name of the memory location and the contents of the memory location. Alright, last but not least, let's create a boolean. And remember, that's true or false. So I'll do variable. I'll give a name of my boolean, and the type is boolean with a capital B. First of all, let's make this true, and then let's output that trace my boolean. Alright, that worked. You can see it spits out the word true here. So there's another way I can assign this. Remember, this can be true or false, or it could be 1 or 0. But I also want to show you how you can create multiple variables of the same type. So let's create another variable here. Let's call it my boolean 2, because I'm unoriginal. The type is boolean. This time I want it to be false, but instead of typing false, I'm going to put a 0, just like that. And what I'm going to do is I'm going to output multiple variables to my output in one go. And all I need to do is separate them with a comma. My boolean 2. So I'm going to spit out my boolean and my boolean 2. Let's test that. Control Enter. And you can see what happens. The only difference is it puts them on the same line. It doesn't put them onto a new line. But you can see it still writes true or false, even though I used a different way of assigning a value. So those are the basic variables that we'll be using in ActionScript, and that's just a little starter on how to actually create them and assign them values and test those values. Let's talk about operations then. We need a means of adding different variables together, dividing one variable by another, or doing a series of more interesting operations that we're probably actually already very familiar with. So let's take a look at the first one. We have the simple add operation, which is quite simply a plus, no surprises there, and a subtract. Well, yep, you know how to do a subtract symbol. However, it's slightly different when you do a multiply. We're actually going to use the asterisk to perform multiplication. And a divide is a /. So let's look at how we apply these operations in code. So inside a new ActionScript, I'm going to create a variable, and I'll just call it my value. And to start with, I'll make it an integer. And what I'm going to do is I'm going to give it a value of 5, and I'll use the plus operation, 5 plus 1, and then I'll trace this out and see what that does. My value, and run that. So as you can see, the output is 6. So all I've done is I've created that variable in memory, and I assigned it 5 plus 1, which obviously is 6. So the output is the value of my value. So as you can see, I can do that as I create the variable. Well, what if I wanted to subtract from that variable that's being created? Well, it's quite simple. All you need to do is call the name of the variable that you want to make a change to, and you could say my value equals my value. Maybe I would like to minus 1 from that. So my value equals my value, which currently contains 6, if you remember, minus 1. And then what I'll do is I'll test to see that that contains what I expect it to contain. So I'll trace my value. So you can see here I'm really using the trace command as a means of testing while I learn how to use these variables. So first it equals 5 plus 1, so it spits out 6. Then I minus 1 from that, so I'm expecting it to spit out 5 here. Let's test that. Control Enter, and it works. The first time it spits out 6, and the second time it spits out 5. Well, what if I want to get a little bit clever here, and what if I want to start trying to do a divide? So remember, it currently contains the value 5. So let's do my value equals my value divided by 2. And let's spit that out. Trace my value. So what is 5 divided by 2? Well, it's 2.5. Let's see what that gives us. It gives us 2. Why is that? Because my value is an integer, and an integer can only store a positive or negative number. It cannot store decimal points. When I divided 5 by 2, the answer was 2.5, and it rounded that to 2. It just chopped off the decimal points, basically. So in order to get this to work accurately, what I would need to do is change this from an integer into a floating point variable. So I do that, remember, using number. Let's test this again with my value being a floating point instead of an integer. And there you can see it works. No difference here, but now I've got 2.5. And you might think to yourself, well, why not just use number or floating points for everything? And it's simple, it uses more memory, so it's less efficient. So you really want to use the type of variable that's applicable or appropriate to the type of data that you're storing in it and the type of operations. So I could multiply that again by 5 if I wanted to, equals my value multiplied by 2. Now remember, my variable current equals 2.5, so if I multiply it by 2, then I would expect it to get back to where we started at 5. Trace my value, and that works. So we've applied those operations, the addition, subtraction, division, and multiplication, to a variable which I changed from integer to number. Okay, well, that's a good start. Let's look at another way to write these things out. I'd like to show you some shorthand now. So I'm going to clear out my output just by clearing that. I'm essentially going to start from scratch. I want to show you a little bit of shorthand here. So what if I created a variable called my value? What I did before, it's type integer, was I did equals 5. Now what if I want to add, say, 1 to this value? Well, I'm going to show you some shorthand. Previously what I did was I typed my value equals my value plus 1. Now that kind of works, but in various situations it could be quite cumbersome to keep typing that out. So a shorthand for adding 1 to a number is simply by adding 2 plus symbols at the end of it. And we can test that out. So trace my value. And you can see that the variable my value with 5 gets created, 1 gets added to it, and so 6 gets spit out. You know, the same works with subtraction as well, which is useful. Minus minus, if I run that, subtracts 1, and so spits out 4. So that's a nice, useful shorthand, and we'll see how that's useful later on when we talk about loops. Lastly, with operations then, let's talk about the fact that we can apply operations from one variable to another instead of having to apply just whole numbers to that. So I have an initial variable called myValue which has a value of 5. I could create a second variable called myValue2 because I'm unoriginal, and I could give that an integer value. Maybe I'll also give that 5. What I could then do is change, or let's see, I'll create a third integer. I'll call it myResult. Type integer. Instead of assigning it a value, what I'm going to do is, because I've already defined two variables up here, the result is actually going to be this integer plus this integer, so it should be 10. So what I do is I say equals myValue plus myValue2, and let's spit the result of that variable out there. So trace myResult. So all I'm expecting to see in my output is 10. And you can see it works. So I created 3 variables, then I added the first 2 together, stored it in the third, and then spit the result out. So operations, very useful, and I recommend you give those a go, experiment with them, and see what you can do. Next, let's talk about conditional statements. So what I'm able to do is assess a situation and look at the result and say, if this is this, execute this command, or if it's something else, execute this command. So I can execute commands based on a certain condition being true or false. So let's look at a simple example, and let's look at an if statement. So what I can do is start with what's known as an if statement. So I can type, for example, what if I wanted to look and say, well, my value currently equals 5, and what if I wanted to test that? And I could say, if my value is 5, do something. So let's start by typing that. So if, and then in brackets we put the test. So my value. Now notice I'm using a double equals here. When I want to assign a value to something, I use a single equals. When I want to query the value of something, I use a double equals. So let's start by checking to see if my value equals 5. So if my value equals 5, then what we do is we say, well, if that condition is true, execute what lies between 2 curly braces. These contain the code that gets executed if this condition is true. So what if I did a simple trace and I typed this is correct? Let's see what happens then. Let's test this. So I'll run it, and you can see that the output says this is correct because my value does equal 5. Well, let's change this up then. Let's make my value equal 10, and let's run this. Now you can see that nothing gets spit out because my value does not equal 5. What I could also do is I could say, well, else and put 2 curly braces and put something other that happens if that condition isn't true. So my other command could be trace this is not true. So if I put this to 5, I would expect this to execute because it is true. But if I put this to 10, this condition is no longer true. This does not get executed. So it says, if my value is 5, execute this. Else, or otherwise, execute this. And because my value does not equal 5, we would expect this to execute. So let's test that. And you can see it's here. This is not true. So by changing this value here, you can make either this condition be true or this condition be true. So we use the double equals to see if it was an absolute value. Well, let's try something else. Let's try a greater than value. So let's do this, which is just a triangular bracket to the right. So remember, my value has a value of 10. And I'm going to test to see if its value is greater than 5, which of course it is. So we would expect this command here to be spit out. So let's test that. This is correct. So it's working, it's executing as we would expect. I can also do a less than operation. So I could say, is my value less than 5? In this case that's not true, so I would expect this to execute instead. Let's confirm that. And you can see that's true here. This is not true. So my value equals 10. Therefore, if my value is less than 5, which it's not, execute this, else execute this. So this gets executed. Another thing we could test for is to see if it's less than or equal to 5. In this case, it's neither of these. It's not less than 5 and it's not equal to 5. So this would still execute. We could also test to see if it's greater than or equal to 5. So this would execute in this case because it is greater than 5. Let's test that. This is correct. Well, what if the value was just 5? It's not greater than 5, but it is equal to 5. And you can see that shows true as well. So this is a single conditional statement here which is being evaluated, and if it's true, this happens, else this happens. What we can do though is we can actually combine multiple conditions together. So let's add another variable. Let's call it my value 2. It's another integer, and I'm going to give this a value of 10. What I can do then is I can test both values at the same time. So I could say if my value equals 5, which it does, and I'm using a double ampersand here, my value 2 equals 10. So this condition would be true because my value does in fact equal 5 and my value 2 equals 10. So I can test multiple conditions, and I could just keep stringing these together by using double ampersands here. So in this case I would expect this to execute. So let's test that. And it does. This is correct. Well, let's throw something in here which would cause it to not be true. So let's say 9. If my value equals 5, which it does, and my value 2 equals 9, well, that's not true. So this wouldn't execute. This would execute. Let's test that. You can see it's working there. This is not true. So we can use conditional statements to compare things and see if we finished a task, if we've got to the end of a level, if we've hit an enemy, for example. We use conditional statements to do that. Well, we can also, as well as doing an AND, we could do an OR, which is what's known as a double pipe, which is this vertical symbol here. So we could say if my value equals 5 or my value 2 equals 9. So we only need one of these conditions to be true. So we've got this one is true, so this should execute. And it does. This is correct. If we change this to say 3, if my value equals 3 or my value 2 equals 9, well, neither of those are true, so this won't execute. So let's test that. And you can see there, this is not true. So let's take a look at the different operators we have. So as we can see from this slide, we have the greater than operator, less than, is equal to, greater or equal, less than or equal to, and we also have this guy here, which is does not equal. So if one thing does not equal another, and that's with an exclamation mark and an equal sign. Now we can stack these conditions together to query multiple conditions at once, just like we did in the previous example, by using the OR operator or the AND operator. So these are the conditions, and we can stack them together using these characters here. Next then, I'd like to talk about loops. And loops are designed to save you a great deal of time, or to execute things a given number of times before something else happens. So, for example, we could say my character has one walk cycle. Well, if he needs to walk from the left side of the screen to the right side of the screen, he might need to execute that walk cycle 5 times. So we could put that into a loop and repeat the walk cycle 5 times as he moves across the screen. So there are 2 kinds of loops that I want to show you, the for loop and the while loop. So what we can do is, let's start by creating a variable, just like we've done before. And I'm going to call my variable value. It's going to be of type integer, and I'm going to give it a value of 0. So temporarily it has a value of 0. So let's do a trace command, and let's output the result of value. So let's test that. And we can see that as we expect, it spits out a value of 0. Well, what if I wanted to add, let's say, 1 to value? I could just do value plus plus, just like we saw before, and output that. So trace value. So first we trace and it has 0, then we add 1 to it, then we trace again and it has 1. Alright, well, what if we wanted to, say, add 1,000 to that? Well, what if I wanted to execute this command 1,000 times? Well, I could copy and paste this out 1,000 times, but that's really inefficient, and it's quite frankly a waste of time. Now, yeah, I know what you're saying, I could just add 1,000 to that, but for the sake of showing you how a loop works, this is what I'm trying to demonstrate. So what I could do is I could put a for loop in here to execute that command 1,000 times. So what I do is I type for, and then within brackets I put a series of conditions, and then I execute a command. So what are these conditions that we need to place in the for loop? Well, first of all, we need some kind of a counter. I want to execute this 1,000 times, so I need something that can count up to 1,000. So what I do is I create a temporary variable which exists only while I'm running this for loop. So this is typically called lowercase I. The type is going to be integer, and there's my counter. Then what I do is I say, how far is this going to count? So I've separated this statement out with a semicolon. I say, while I is less than 1,000. Now I'm doing less than 1,000 because my initial value, my counter, is initially going to be at 0. So it's going to go from 0 to 999. So it's going to execute 1,000 times. Then lastly, we type how many we increment the counter by each time we run through the loop. Well, we're counting 1, 2, 3, 4, 5, so we want to increment by 1. So I plus plus. So what we're saying is create a counter, start it at 0, count while it's less than 1,000, so in other words count from 0 to 999, and add 1 to the counter each time. Well, what are we going to execute each time we're in this for loop? Well, I'm just going to quite simply write value plus plus. So what's going to happen here? When we first run the script, we create an integer called value, and we set it to 0. We check the result to make sure that it is 0, and then we start a loop, and 1,000 times we will circle round and add 1 to value, and then we'll spit the result out, and we should see 1,000 in there because we start at 0 and we're adding 1,000 to it. So let's test this. And you can see it's working. First time we trace, we have a value of 0, then we add 1 1,000 times, which gives us 1,000. And so that's a for loop. Very, very useful for shortening up repetitive commands. I could be really clever if I wanted to here. I could trace or spit out the result of value each time I go through the loop. So not only do I add 1 to it, but I write the result out. And what will happen here is I'll see this counting from 0 to 1,000, and then it will spit 1,000 out one more time. So let's test this. And you can see it did it so fast, but if I scroll up here you can see that each of those numbers got spit out. So a very quick way of repeating a series of commands a number of times. That's a for loop. Let's now look at a while loop then. So a for loop is one way of creating repetitive commands. A while loop is very similar, just slightly different syntax. The way this works is, first of all, we create our counter. So I'm going to create my counter I. It's a type integer, and just like before, we start our counter at 0. We then type while to initiate the loop, and we say while, and we put a condition in here. So if I want to execute this 1,000 times, I say while I is less than 1,000. That means it goes from 0 to 999, which is 1,000. While it's less than 1,000, execute what's in these curly braces. So what I could do here is I could add, let's say add 2 to my integer called value. So I could say value, and if I wanted to be really clever I could go plus equals 2. which is just a shorthand way of saying value equals value plus 2. So all I'm doing is adding 2 to it. And I'm going to do that 1,000 times. Now, I could trace the result out, which of course would write out that result 1,000 times. And you might think, okay, I'm done. I've got my counter, I've got my condition, and I've got my statement to execute. But you're not quite done, because our counter starts at 0, but it never increases. So what's happening here is I is always less than 1,000, and what you've got here is actually a mistake, and it's a loop that never ends. So it's an infinite loop which will just crash your program basically. So it's really important when you're using your while loop, you must increment the counter. We have to add 1 to it. So we got our counter. While our counter is less than 1,000, add 2 to our integer, spit the result out, and then add 1 to the counter. So we'll do this 1,000 times. So let's test this. You can see it worked. This time it counted up to 2,000 because I added 2 each time instead of 1. So, very similar to a for loop. Which do you use? Well, a lot of it's up to personal preference, to be honest with you. I typically use for loops because they're convenient, because it's all in that one opening statement. They're a little easier to keep track of. Often I'll write these and I'll forget to increment the counter and accidentally crash my program. So really it's up to you. At this point I'd like to talk a little bit about debugging, and all that really means is finding errors that you've made in your code. You know, we're all human, we all make mistakes, and often we type something out very fast and it's got an error in there, so it won't compile correctly. Now, the ActionScript editor in Flash has a built-in debugger, which is really useful. So let me give you a brief overview of how this works. Let me intentionally make a mistake here in my while loop. So, say for example, I wanted to create my counter, I, but I didn't give it a type. So what if I removed the type there? It's missing. What happens when I try to run this? You can see it tried to execute it, but it also spat out a compile error. And these are key for finding where you've made your mistakes. Sometimes they can get a bit convoluted. It's only as good as, you know, the humans that program the debugger, so it doesn't always get it quite right. But it says here, line 3, expecting identifier before assign. Let's take a look at line 3. There it is. You're right. There's no identifier there. There's no type before we assign a value to it. So we can put that type back in, integer, and this time it does run correctly. Okay, well let's try something else. Let's try making our counter, instead of an integer, let's try making it a string. So I'm trying to put a number into what essentially should hold a word. Let's see what happens now. Uh-oh, that doesn't look good. So we've got a number of errors here. So implicit coercion of a value of type int to an unrelated type string. That's a really fancy way of saying you're trying to store a number where you should be storing a word. Get it right. So that's all that means. And then later on that causes more problems, line 8, line 4, all because I messed up this type here. So whenever you see these compile errors, look at the line numbers, and those will give you a clue as to what has gone wrong with your code. Next then I'd like to talk briefly about the idea of a function. A function is simply a way of saving you time, because you can write a block of code and then execute that block of code just by calling the function name itself. So if I wanted to, for example, write a series of code that displayed, you know, an arrangement of circles and squares on my stage, well, every time I wanted to repeat that, I'd have to write that same code out again. But if I placed it inside a function, then every time I wanted to repeat that series of circles and squares, all I'd need to do would be to call the name of the function that contained that code. So, to better explain how these work, let me show you how you write a function. And you'll be using these frequently. So you use the keyword function, and then you give it a name. So this can be anything you want. I'm just going to call it my function. And in its simplest form, you just use an open bracket, a closing bracket. That's how you declare a function. And then, underneath it, within curly braces, is the contents of that function. So what you want to get executed every time you call the function name. So say, for example, I put a trace command inside my function, and it says hello. Well, I've created a function, and this function contains this code. So let's see what happens when I execute it. Absolutely nothing. Nothing comes in my output, and why should it? All I've done is create a function. I haven't actually executed the function. So, in order to execute the function, in other words, this code here, what I do is I just call the function by its name with the opening and closing braces, and don't forget to end the line with a semicolon. So I'm declaring a function here, and then I'm calling it here. So let's see what happens now. And you can see in my output it's executing that trace command. Well, okay, how's that saving me time? Well, if I wanted to execute that function 4 times, I just call it 4 times. When I run this now, hello gets written 4 times. And in this simple example, you're probably thinking, well, I could just write trace hello 4 times, and you could. But what if this function contained 10,000 lines of code? If I wanted to repeat those 10,000 lines of code, I'd have to type them out each time I wanted to execute them. Using a function, you can save time by just calling the function by its name. Very, very useful, and we'll get more into that later on in the course. The last thing that I'd like to talk about then are the use of classes and objects, and more specifically the fact that ActionScript is an object-oriented scripting language, much like JavaScript or a programming language like C++. So this means that you can use classes, and from that you can build objects. So let me try and explain this. You can think of a class as a blueprint. It's an instruction set, and perhaps a shopping list. It's an instruction set on how to build an object. So think of it like this blueprint here on how to build a Lamborghini Murcielago. This would be the class. The object is the thing that actually gets built from the blueprint. In this case, the real-life car, the Lamborghini Murcielago. So classes and objects work together to save you time, and it's a more intelligent way of programming. Because if I have my class on how to build my Lamborghini, I can build one object, but perhaps I wanted to build that car twice. I could build a second version, and so I'm using the same blueprints to build 2 cars. And I could go nuts, and I could build a third version of the car. And each version of this car could, for example, have a different state. So if I were including these cars, these objects in a game, I might have different speeds allocated to each car. So the first car could only go 0 to 50, the second car could go 0 to 100, and the third car could go, 0 to 200 miles an hour. So I can give it different states depending on how I want that car to be defined. So think of the class as the blueprint, the instructions, and think of the object as the actual thing that gets built from those blueprints. Another way to think of classes and objects is by showing you within Flash itself. Say, for example, I built, let's say a primitive snowman. So for the sake of explaining this, this is a snowman. I know it looks pretty bad, but you're familiar, I'm sure, that within Flash I can select these shapes, I can go modify, convert to symbol, and I could call this snowman. And what this does, I can even delete this from my stage now, is this creates the symbol in my library. Think of this as your class or your instruction set, your blueprints on how to build a snowman. What I could then do is drag out an object that's built from this class. In fact, I could drag out 2 objects or 3 objects. So I've used that snowman class to define 3 objects that have been actually built and are on my stage and being used. I can give these slightly different states or parameters. So for example, I could use the transform tool. I could scale one of the objects down. So each object has a scale. I could give one a different rotation. So each object has its own built-in rotation. And so this is being stored in the object which is getting altered. So while they all came from the same blueprint, they can all be manipulated because they have these different properties within them. Let's see how this idea of classes then works with ActionScript directly. So I'm going to delete these objects, and everything I've shown you so far has been applying code directly in to the frame, which is, well, it's kind of a primitive way of applying ActionScript to your Flash projects. A more effective way to do it, and in fact how you should be doing it to create games and such, is to actually make use of external ActionScript files, or more specifically classes. So the way you do this is, I've got an empty scene here. The first thing you should do is actually save your Flash file. So File, Save As, and I'm going to put this in a folder on my desktop called Example, and I'm going to call this Hello. So what I'm going to do is actually attach an external ActionScript file or class to my Flash file in order to link it with that code. And it's kind of similar to creating a CSS style sheet in HTML. You'd create that externally and then you can attach it to multiple HTML pages. It's a very similar concept. So what I'll do is go File, New, and what I'm going to do is go to now, when we create a game in Flash, what we typically do is we create a single class that has all the code to get your game started, and you can have multiple other classes called by that class, but this is typically how it's done. And so the way we'll do this is we'll go to the Properties panel in Flash, and you'll see Class written down here. And this allows us to create and attach an external ActionScript document. So it says document class there. So if I click on this little pencil here, edit class definition, it says, what do you want to call this class? And typically in Flash, what you do is, or the rule of thumb is when you're getting started, use the same name as the Flash file itself. So my Flash file is called hello. So I'm going to call this hello, and then I'll click OK. Now what this has done is it's taken me into a separate tab, and it's called Script 3, or in your case it might be called Script 1, and it's given me a whole load of ActionScript. Now what I'm going to do next is be very careful on how I save this script out. So I'm going to go File, Save, and I'm going to be sure to give it exactly the same name as my original Flash file, hello.sh. AS, which stands for ActionScript, and click Save. If I come back to my Flash file and look at the class definition here, it says hello, and what this means is it's going to look for an ActionScript called hello. If I bring up the location of that example folder, you'll see that it can find that because it's got hello.actionscript. If I were to rename this to something else, I'd break the link. That name there has to be the same as the ActionScript file that's directly located in that folder. Alright, so we've created our external ActionScript, and what that's done is it's created a bunch of default code. Now that's really nice because if you use this method you don't have to worry about typing this out each time, and I'll just briefly explain what this does. First of all, we're going to contain everything within a package, and so it uses this keyword package and says this external ActionScript contains all this code from this opening curly brace to this closing curly brace, and that's known as a package. Then what it does is it imports some libraries, just like we did when we created the text field earlier on. In this case it's importing movie clip by default. And the reason it's doing that is because it's attached to a Flash movie clip. And so it needs to be able to know how to handle that. Don't worry about it too much, let's move on. This is where we're creating our class. You can see that because we're using the keywords public and class. You'll notice that the public word has been used, and all that's saying is this class can be executed by this movie clip. Later on we'll possibly use private. That means that you've got restricted permissions on what can actually use that class. So you've got the keyword class, and then we've got the name of the class itself. So in the example before we had the Lamborghini Murcielago. Think of this as the blueprints. The class name also has to have the same name as the ActionScript file and the original Flash file. Now the reason we're doing it this way is so that when you execute or build this animation, it automatically links to the ActionScript document hello, and within the ActionScript document hello there's the class hello. Now this is known as the constructor class, so essentially this is automatically being run. If you set it up like this you won't need to worry too much about it. And within that we have a function. This is known as a constructor function, and I've defined a function just like I did before, except I'm using this public keyword, and again we give it the same name hello, and this ensures that this gets executed as soon as we run that animation. So by giving everything the same name, hello, here as the original Flash file, everything will get executed by default, and that's known as constructor code. So that's how we create an external ActionScript document which itself has a class, and inside that a constructor function which gets executed by default. And remember, all a function is a chunk of code that gets executed. The class is essentially extending the functionality of the original movie clip, and it's exactly what it says here, extends movie clip. You're extending that movie clip so that it can do additional things that are described within this hello ActionScript. So this class is really the blueprints on how to build our game. When you run the Flash file, it builds the game. Let's actually put this to the test then and give it the similar code to the Hello World program that we did before, and this time the only difference is instead of putting that ActionScript directly in the frame, we're placing it in this external ActionScript file. So here's my constructor code. In other words, this gets run as soon as I compile my Flash movie. So just like before, let's create a variable I'll call it my text, and the type is text field. And incidentally, what's interesting to note is that, remember I said that this was saving you from reinventing the wheel. This is the blueprints on how to create a text field. This is a class all to itself. When you do new text field, you're calling the constructor function to go ahead and build that text field and create an object called myText. So you'll see that a lot within Flash action scripting. So once we've gone in and built that myText object, let's go ahead and adjust one of its parameters. So the text variable, which is stored within that object, and let's give it some text. Hello world, and end the line. And then last but not least, we'll add the child to the stage, myText. So all we've done is we've called that text field class, we've built an object called myText, just as if I'd used the text tool, dragged it on the stage and typed in some text. I'm applying the text here with hello world, and then I'm actually putting it on the stage. Let's test this then. The way we test this is we have to save the ActionScript file because it's an external file. So we go File, Save, come back to the original Flash document. I'm going to save this to, and then I'm going to run it. So just Control Enter. And there you go. We see it works. So when I run this empty Flash document, or seemingly empty, what it does is it looks at this class which is attached, which is this external ActionScript file, runs the class, sets up the constructor code, and then goes ahead, builds a text field, gives it text, and outputs hello world to the stage. Simple as that. So what if I closed these documents down, looked at the folder that contains these documents, and here's the Flash file, here's the external ActionScript file, and here's the Swift file that got built when I actually built the Flash animation. So that's actually been built, and I can run it freestanding now, and it goes ahead and runs my ActionScript. You can send this to someone just by itself. It's all packaged nicely together. If I wanted to load this up again, what I need to do is first load the Flash document, and then I'd need to bring back that folder, and then open up the ActionScript itself. So I have to open up each of the files one by one. Well, what if I close these down, and what if I wanted to rename this to hello script? Well, when I load this up, you'll notice that, yep, it's called hello script, but it links to a file that it's looking for called hello. That link is now broken. Well, the truth is, it's not really broken, it's still there. It's called hello, so it would find that file, but within that file it's got the class called hello and also the constructor function called hello. So what I'd really need to do is rename this from hello to hello script, and then load this one up. I'd now need to point the original Flash file to hello script, and then I need to change the name of the public class, hello script, and the name of the constructor function that gets executed by default, hello script. Long story short, if one of these file names changes, then you need to go ahead and update the others. So everything, the function, the class, the name of the ActionScript file itself, and the Flash file all need to point to the same name, at least when you're first getting to understand and learn ActionScript and external classes. This is very essential. If something goes wrong early on, chances are that these names aren't linked up correctly. So if I save this, and then execute it again, you can see it works. So that's the basis of getting started in ActionScript. We've covered a lot of material, so you might need to revisit parts of this video again in the future. We've covered basic coding concepts, we've covered variables, getting started with standard ActionScript directly in the timeline, using those variables to create loops and conditional statements, and then we've looked at how to not embed the code directly in the timeline, but how to put it in an external ActionScript file and how to link that into your Flash file. So if you have any questions, please do contact me, and I'll be happy to help you with any issues you might have. And thank you for watching this video.